Everybody, welcome to a late night stream, late night for me anyway. My name is Kevin, and this is a continuation of the ESP32 product creation journey. I've got a bunch of things to cover this evening. I'll stream probably be about an hour, but I want to talk about the battery test that we did last time, and I've got results from that. And I'm also going to continue on with the printed circuit board modifications that we want to make. I had a breakthrough of an idea that I think will work, and we'll start walking through that and see how far we get. So first things first, however, let's talk about the battery test that we hooked up. And if you remember, I had a circuit hooked up that was going to if this then that, IFTTT, going over to a Google Sheet with a voltage reading every 30 seconds, I think it was. And so I just wanted to show how that went. First of all, let's come over here to full curve first. This was the discharge curve. Now, it's kind of noisy, but I think that's okay because again, I don't really care what the specific voltage is, just that when it's getting low, I can put some sort of indication on the display or, notify the back end or send an email or do something to help people know that it's time to charge the battery. And what I thought was really cool about this, despite the noise, is if you look here, this is just a random picture from Google Image that shows kind of the characteristic curve of a LiPo battery discharge. You can see it kind of starts out, comes down, then it goes through this sort of linear phase, and then it just drops off the edge of the earth over here. And you can see that here, there's a little bit of a steeper curve right here, and then it's kind of linear all through here, and then sure enough, it just drops off the face of the earth. And right around here, I originally said because our schematic goes from the LiPo through the PMIC and then through a linear voltage regulator that I thought it would drop off around 3.2 or 3.1 volts because the voltage regulator has to output 3.3 volts, but really cool, the battery went all the way down to just under 2.7, which is the cutoff. The circuitry in the battery cuts it off at that point to prevent the cell from being damaged and unrecoverable from deep discharge. And so it was like at 2.69 volts is right here where it stopped reporting in. And so kind of cool to see that the discharge curve followed that perfectly and that the battery even kept it running below 3.3 volts. So really cool. We're getting the most out of the battery through the power circuitry. That's really cool. So I thought that was fun. The next part of this, I'm going to close this discharge curve. Let's bring it over here actually. Was the charge curve. And so if you remember, this is from the data sheet of our PMIC. Now, this, it says typical charge cycle. This is exaggerated, right? So this is an actual linear time across, what we call the x-axis. It's just showing that like in the pre-charge phase, it's kind of like this, curve up. And then in the fast charge, it's linear. And then at the end of that, it starts to taper off and then it's just constant voltage at the end. Well, if you look at after I completely ran the battery dead from the first test, I put it on charge and had it report through the charge cycle. And you can see like right here, we're in pre-charge, sort of this as it ramps up. And then I'm not sure what this blip is right here, but if you look closely, and it's a little hard to see, right after this blip, it's very linear all the way up through here. And then right around in this area, you can see it start to taper and the angle, if you use this line as a reference, the angle is less here. And so I'm imagining that's, right in this phase right here. And then eventually it gets all the way up and we're back to a fully charged battery. So I was really happy with how, first of all, how the test sketch worked with reporting the voltage and how, I don't want to say surprised. I shouldn't be surprised. This is just the physics of how lithium chemistry batteries work and how chargers charge them. But it was really cool to see like a sketch that we wrote that was reporting this data every 30 seconds for several hours show the expected discharge and charge curves. So that to me was really cool. I'm glad that worked out in the test. Success, right? Like I think what that proved is this idea is will work. I can clean up and filter this to make it a little better to read. And then again, putting the feature on the board is what we're trying to do now. We can worry about the firmware that uses it later. And so that's where we're at. I'm going to grab this and put it back over on my other screen here and get rid of this as well. Okay, so let's talk about the changes that we need to make to our printed circuit board. So last time we were talking about how we have to get a few connections going. One of them is here's where we put the voltage divider that comes off of VBAT, battery voltage, and then it comes all the way down here to this pin right here. And I was thinking about ways to kind of navigate that. And then I also got stuck at the end of last stream about I've got to take the BCD, the battery charge detect, and the power enable signals out of the FTDI chip, get them down to the PMIC so that we can set the charge voltage correctly. And currently, I have these 3 resistors that are kind of in the way that make it hard to get the signals down here. And then I realized something. Let's come over and take a look at the schematic in our PMIC. And that is, we're using battery charge detect for 2 things. We're going to pull the charge enable low when we detect a charger, as well as the enable 1 pin. And these have 2 different pull resistor values on it. Pull up in this case. Originally, we had pulled CE down always so that charge was always enabled regardless of what we were plugged into. I covered this in a previous stream where that completely violates the USB current requirement spec, and so we're trying to fix that. So this was pulled down, not to 5 volts, so this used to be ground out here through a 100K resistor, and then this was previously pulled, one of the enable 1 or 2 pins was pulled down. I can't remember if it was this one or not, but what we want to do now is we want them both pulled up, as you can see, and we want BCD to assert them down when it detects a charger. And so there is no reason that I can think of that we need to have 2 separate resistors, let alone different value resistors, now that this is how we are doing things. And so I think what we can do is simply pull them up through, we're going to use the 10K resistor. And so essentially tie the CE to the enable pin right here and have them both pulled up with just a single pull-up resistor to 5 volts. And I think that will be just fine. And so they'll both, again, in a normal state without any BCD input or influence on the circuit, they will both be pulled high to 5 volts through a single, again, through a single 10K resistor. And I believe that's fine because in some of the examples of the datasheet for this, CE and enable 1 are tied together, and they're either tied to ground or to something else. And so I think what we can do is let's just start making changes here. I think we can get rid of this, and that, and this. Start getting rid of this stuff, and then just get rid of this too, and then straight up take a wire from here to there. And so now CE and enable 1 are both pulled up to 5 volts through a 10K resistor, and then when a charge is detected, this will pull it low. And in fact, let's move this up to here instead of having it hang off down in this sort of little no man's land. Yeah, and then we'll wire it like that. All right, I think that looks good. So pulled up normally, so they'll both be high, which is what we want. And then this will assert them both low. So that's going to save us on resistors. So I'm going to save those changes. And now let's come back over to the schematic and let's update it. Why does it not? Changes applied. Like we should have lost a resistor in this process. Why didn't we? We definitely got rid of a resistor. Why is it not? Let's highlight this resistor. And then come over here. That's this one. Yeah, why are these? I would have expected. Now if we go to schematic, like. One of these resistors is not required. This is R5. That's R5. No, they both can't be R5. This is R10. 10K. This is R5 100K. So it's really weird because R5 we got rid of. Yeah, R10's there. This was R5 right here. So that's interesting. Annotate. Use entire. Let's do annotate. And let's come back over and really like delete extra footprints. Remove unused footprint R5. Okay. Okay, so maybe that's what I wanted to do. And then update PCB. Haha. There we go. Now that resistor is gone. Okay, great. And now you'll see BCD is just, if you can just connect these two pads together, we'll be all set. Now, so that's helpful. We got rid of one resistor. And then what I realized as well is before these were connected to 5 volts just right here, I think what we could do is move those resistors up into this area, which then gives us all kinds of real estate through here. And so I'm remembering, I thought about this last time and I hadn't thought about it. I was just thinking, why do I care about having all this room through here? And the second part of this is if we can move those resistors up here, we could take these two voltage divider resistors and instead of grabbing VBAT from up here and then trying to run a trace all the way down here, when I was looking, and this is something that I found helpful as I'm doing layout, is when you you zoom out, like when you're looking at it like this, it's kind of hard to get a full picture and vision. But when you just scroll out a little bit, and sometimes I'll just stare at it like this, and I start to see like, I need to get a trace to this pad, and then I'll look. I'm going to turn off the bottom layer for just a second. And that helps too. It kind of makes it less noisy. You can see, I can come up through here. I've kind of got a pathway through here. And then I've got, now I'm running into this, but I also have a clean path right over to here. Like there's no traces that I'm going to cross over coming over to here. And look what's just right nearby VBAT. So if I could somehow get my voltage divider even right up in here, I should be able to get it there. And it's like the only thing that's in the way is this. Well, let's turn on the back and look at it. Oh, that's just where I decided I was running this one down. I couldn't run into this line. And so that's where I decided to punch through the board and pick up on the bottom. This I could easily, this via, I could easily move up some. So I could just slide it up. And then I've got a clear path that comes right through here. And again, I could put that voltage divider right in here, maybe even right in here, and grab the VBAT off of this location instead of way up here. So let's start working on this and see how it goes. So I'm going to grab this and move it out, and this and move it out. Because remember, these are pull-ups on now, like they were pulled right from the PMIC, but now they're really pulled from here. The signal originates from here. And then that gives me a bunch of room in here. So let's, as part of this, I found I'm going to have to do some changes around here. And I noticed one of the things I noticed when I was looking at this after our last stream was, if you notice this via pretty small, pretty small, pretty small. This big 5-volt one is, you know, taking this fat 5-volt trace and dropping it down to this green one on the bottom. I have no idea why I made this via over here gigantic. And so I'm going to, I can't quite change it right there the way I want to. So I'm going to make sure my via is the small one selected here. 0.6 millimeter, 0.3 millimeter. I guess I could just change it. Via diameter, we'll say 23.6 mil and 11.8 mil. No, let's just try that. There we go. It looks much better. And then can I just move it? Okay, not really. Okay. So let's, and then puts a big X on there. Let's Control Z that. Control Z that. Let's just delete it for now. Deletes the whole trace. That's not what I wanted to do. Okay, good. That just deleted the via. And now you can see I have an X here. And the reason I want to mess with this trace is because here's where the BCD line is and the power enable. So I want the pull-ups to connect from here to 5-volt, and then run down. And it just so happens, look what runs right through here, 5 volts, like it's right next door. And so if I could, I don't know if I have to move this. Let's zoom out a little bit. Let's grab one of these resistors. Okay, yeah, I'm gonna have to move it. They're fairly big. So what I'm thinking is something like this. And so if I do that, maybe up here so I can put the power enable one right next to it. You know what's funny? I just realized if I drop that like that, it's actually touching. Like, that would work. Like we could draw, I don't know why it's still showing the rat nest, but we could wire draw. I mean, that is doing what it needs to. Maybe that's what we'll do. And then I can do the same thing with power enable. And then I just need enough space to break the signal out. So what I was thinking is, let's swing this trace out more this way, 5-volt out more this way. Give me enough room to punch some vias through. And then I can run those to power enable and BCDs on the back side all the way down, pop them up right where they need to go here. And then I'll have enough room to get to escape VBAT out of here as well. And again, I won't need as large of a trace as I have coming through here, because this trace will be carrying the current that's powering everything. The trace that'll come off and go through the voltage divider is just a very low current voltage providing source, and so I could use just a 8 what am I using, 8 mil trace to pipe it over. I think we can make these pretty quick. So let's first start by moving. Let's see if we can just grab this hate how that's going. Escape. What if I grab it right here on the elbow? I don't want to create weird angles. So like if you see this, let me drop it here. This angle here is different than this 45, and it's fine. The Fab House can do that, but it doesn't look neat. And so what we're gonna do is this. We're gonna highlight this net. We're gonna delete it. We're gonna delete this. Easiest way to do this, I'm gonna just leave that like that for now. Um, yeah, and then we'll redraw that in a second. And I'm gonna do the same thing here. I'm gonna delete that. I'm gonna delete that. I'm gonna delete that. And just knowing that I've got to get 5 volts back up to here, and I've got to get this routed back up and around to here. I'm just going to swing it out wider, but let's first get my resistors in place the way I want them. Okay, I want to rotate that so that the 5 volt is on the outside. We're going to put them right next to each other like that. Let's maybe slide this up a little more. What's our grid set to? We're on 10 mil, so that's fine. No. I need to push these out, I think, a little more. Oh, no, that's going to the ground plane, so that's fine. Let's put it back. And then let's move this guy back down. Again, as a reminder, I talked about last episode, the white is the courtyard, meaning it's kind of the physical, mostly the time it's the physical size of the component, so you don't want them to overlap because then they'll be, they might not place right. And you can see I have this, I'll highlight it. This part right here, that's the battery connector. And even though the courtyards overlap here, it's okay because this is actually, this J2 is on the back side of the board. So it doesn't matter that they overlap in this case. And you can see that indicated by like the courtyard on the front here is white and the courtyard on the back is this light gray. So it's okay that those overlap because they're on different sides of the board. And so this isn't going to work either because, so BCD, I can punch out right here, go under the board, and then start our way down. Let's zoom out so we can get a better look at it. But power enable, I'm stuck. Like, how do I get it? How do I get it down? And so what I think we'll do, let's just mess with the orientation here a little bit. What if we did something like, well, hold on. Let's. It's good to go through a few ideas. Let's play with this a little bit. What if we? Okay, so 5 volts again is right there. So if we did something like this, we can come straight out to BCD. We can actually move it down a little bit. No, we're not going to move it down a little bit. Like that. And then we could come right off of here and punch down. And then we could do a similar thing right here. We could put them like this. I feel like I like how this is coming. And then 5 volts right here. I just come up around, connect to 5 volts here, and then we go. I could even run this trace all the way up through here and via it right there. I won't. I'll via it over here. I think I like this a little better. And then I can come out, do a via right here for BCD. I think we're gonna go even higher with this, like that. And then that gives us enough room to get power enable out. And we could put the power enable via right here. I think that's going to be a little nicer. Let's zoom out, take a look at it. I'm okay here. Oh, I'm not okay here. Look at this. I'm overlapping. Which I wonder if the DRC will pick that up. Continue without refill. Courtyards overlap. See there? Love that. So cool that KiCad does that for us. And look at that. It even puts a little arrow like right here. Okay. Computers are amazing. Okay, I would need to, let's just do that to give them a little more space. Okay. Yeah. Now it's just going to say I've got a bunch of unconnected. Great. Okay, I think I like this. So let's grab our wire, make sure this is turned on, the auto track width, so it'll just pick up the track width of whatever it was last on. Now that's connected. We're going to come out of here and I don't know that I want that to be. Oh yeah, that's fine. It doesn't need to be that width though. What is that? That's 10 mil. It's got to be 10 mil. $9.8. Oh, because it's matching the pad. Okay, yep, nope, I don't like that. So now we're gonna turn this off and we're just gonna select yeah, 9.84 mil. We're just gonna select 8 mil. Which is, I believe, what everything else around here is. Connect to that. And then this is 8 mil too, right? Yeah, 8 mil. Okay. And then do the same thing for power enable. That's not the right size. Why is it 10 mil? No, 8 mil. Okay, like that. We'll pick this right back up. And then it's interesting that, oh, it's saying I got to connect it to this trace right here. Okay, yeah. So you want to just come out. Do like that. Actually, the way that the KiCad routing does, you can see, let's just zoom ultra in. It puts it just right tight on the pad here, and I hate it. So let me just, I like to come out a little further. and then have it auto route. There, like that. Okay, so my 5-volt is connected there. Let's save that. And great. And now all I need, make sure the V is set to my smaller size. It is. And now I should be able to come right off of here. And if I press V, okay, it's a little tight still, but it will put one there. So let's make it not so tight. Let's come back to here. And let's make it not so tight. There we go. That gives us some more room. Okay. And now we still need to reconnect this, but we'll come back to that because now that we move these up here, we can come off of here, do a via right there, and basically just we'll move this, but I'm gonna let's just come to here and stop and then zoom out. So that is fine. I don't want to break over on it. Okay. And then the same thing for power enable. We can actually just right here punch a via. Nope, I want to be on the back side. And then the same thing, I can just run right down through here. And then let's take a look at that. So power enable, BCD. And then power enable is pulled up. BCD is pulled up as well to the same 5 volts. We ran them down. And then they have to cross each other. So it might have been better for BCD to be on this side and power enable to be on this side. And to be honest, we can just program them that way. And then we don't have to worry about crossing them. Because I also need to come up through here. With my voltage divider. Okay. And what I mean by switching them is like right now I've got this is BCD and this is power enable. I can just these C-bus pins are all programmable. So I can make this power enable and I can make this BCD. Something that just occurred to me while we're doing this is the default of those pins matters. like before we program the FTDI chip for the first time. No, it doesn't matter because we won't be trying to charge the battery anyway. Yeah, it's fine. So BCD and power enable. It's not a big deal to switch them. Then I need to get to both. It's almost like I need to pop BCD out higher, like right here. So let's just carry this out to completion. There, and now we should be back on top. And we just run this straight in. Great. And then we also run this like this. Nope. All the way out here. And in. And then we can continue running this. Why did it? Oh, it does that because of the. And then we drop a via right there and do that. Ugh, it's ugly. But anyway, it satisfies the electrical rules check. Okay. All right. I hate it. And I think we either find a way to switch them up here, like punch the power enable via out here so it's on this side, and have the BCD one run underneath through here. And then we can just push this out even more. Because we're going to push a via in right here and make this all under anyway. Yep. Let's I'm going to just try that for fun. Okay. Clean all this mess up. Okay. And then get rid of this and this, this and this. And then get rid of this. I've said in a previous stream, wait until the very end. Okay, I see. Now I see something completely new that we're going to do. All right. We're going to get rid of all of this stuff. Okay. And that as well. Okay. New plan. This is why you look at it enough times, you get better ideas of how to pack it in tighter. Okay. So we're going to move this resistor, because there's nothing below it, down here. Like that. We're going to move its silk screen as well. And we can get rid of that. And actually, I'm going to hide the silk screen. because it doesn't really matter where that stuff is. And then we're going to grab this one. We're going to slide it right in like that. And that, look how pretty that's going to look. These 3 resistors just right in a row. That makes it much cleaner. And then we've cleared out some space there. I like it. And now we can come back to wire mode, 8 mil, straight out of here into that. That looks really clean. Straight out of here into that. Almost straight out of here. That's okay. Oh, yeah, that looks so much nicer. Connect this back up. And now we just come out of here like that. Oh, that looks so good. You see, and sorry, I'm a symmetry person, so you can see like this comes up like that, and this comes down, fans out, and these go straight. That looks really nice. I really like that. Yeah, and then that's what we have to run around to this other net, and that's okay. We'll do that very last because we're gonna have a lot of room to do that. And yeah, I really like the way that that's looking. Okay, now, which side did I say I want to power enable on? Power enable on the outside, BCD on the inside, right? It's getting late for me. So basically, we're going to bring one of them out further, one of them out closer, and then come straight down. BCD on the inside, power enable on the outside. We'll punch power enable up close to the chip and finish it. We'll do BCD further back so it can cross over and come down and down. Yeah, BCD on the left, power enable on the right. Okay, so I'm out of here and just as close as we can be. Will it let me, will it let me put one that close? It will, huh? Okay. I guess it doesn't care. It's going to move it a little bit. Okay, yeah. And BCD, we want to pop up further back. So like right here. And then we just finish out this trace. Now, let's see how it auto-shaped things back up here. Oh, that's not bad at all. And then I should have plenty of room for the other one to come down. Let's draw this one from the bottom up. And it's going to come right through there. It's going to squeeze right through. Okay. Power enable is going to come out, and then it's going to break right there. And then, yeah, just like that. And then put another via right there. And come right into it. Okay. That looks much cleaner. And it kind of scoots around. That's okay. I could even probably slide it a little more. Like if I grab it. Oh, nope, can't do that. That's okay. And the reason I can't is because this has to have enough clearance there. But it's fine. It comes down through, goes there. And now we can just, on our top layer here, grab BCD. Nope, that's the bottom layer. Grab BCD and just do that. So both of these go up all the way up to here. They get pulled up to 5 volts and they're also attached to BCD. Okay. I think that's what we want. I forgot, while we're down here, I'll do this last. I'll do this after the stream. Let's get these friends up here. Nope, I'm still on the wire. Move. I want you to be like down in here somewhere. I want you also to be down in here somewhere. And I'm going to take VBAT and just come right up through here. Grab that. Move this out of the way. Yep. Okay, I don't know what I just did. We'll move that out of the way. We'll come back to connecting that. But here's our voltage divider. Let's wiggle these around. Hopefully we have some ground. Line it up like that. If I could do this just a little. Like that. This one could come over. If I could just get this one up. Oh, wait, I can. I want them lined up like that. And I should be able to get ground, presumably through here. Yeah, it's going to go through there anyway. Okay, so if I just put those right in there like that, looks like a nice place for them. I kind of stagger with these, pretty good. And then all I have to do is grab VBAT off of here. I can come right up through here and attach that. And I can come up through here and down. So maybe that's still, no, I want the via to be, oh, I can't put the via. All right. Where am I going to put that via? Up here. I'm going to put it up here. And then this can move all over the place. So the wire. Oh, I hate that it's drawing it like that. I'm guessing because of my grid. Let's change it down to 5. Like that. And then I want the via to be up in here. Now, yeah, like that. Okay, so we slid that via up, which now gives us a rather nice path. In fact, let's move these. Down just a hair. Like that. Great. And then again, we only need 8 mil traces coming off of the bat here. Let's turn this off again and go back to 8 mil. And oops, back to wire. Just like that. Take the battery right out. And then these two have to connect to each other. Easy peasy. Now we've got a beautiful path right down there. Okay. That looks good. And I believe if we fill, that's everything. Let's run the DRC. Unconnected items, 3. I know exactly what they are. Let's click on them now. It's hard to see the arrow. It's this. We need to connect this up here. So let's unfill. We need to come back down like we said, and we have to connect the 5 volt as well as the, yeah, okay, great. We should be able to wrap this up. Okay, 5 volt just has to come up and around like that. And then this also has to come up. And let's just up and around. We can just via it right here. Bloop. I don't like right angles, so something like that. Okay. So that I think is, it said 3. I just resolved 2 of them. Let's run it again. I think all of these are going to be ground. Again. One unconnected item. Right here. Okay. And what is that? Oh, I see what we've done. Ground. So let's fill it again. You can see that we've created ground right here. But we have no way to get it into here. So we need to get ground. Oh, okay. So that's the problem. The problem is this needs to be connected to ground. And before I was using some ground plane here. How are we going to do that? We could run just like a real small trace into here. But ultimately, we need to get ground. It won't let me punch a via right here either, I don't believe. Like, we just punch one, right? No, because there's no ground under there, like right here. Like that would be the easiest way to do it, of just sticking a via in the footprint that connects to the ground plane that's underneath. So essentially what it's saying now is the TDI chip is not grounded because the fill rules don't close this gap. So How do we fix that? We could take a six mil trace. Can we get 6 mils through here? No, we can't. Okay. I will figure out how to solve that. We might need to do what? Move. Sucks. How do I get? I suppose I could try to come off of this and get out into here. Okay. This is our solution. That fixes it. It's not great. And I don't. Okay, but that would, like if we run the DRC now, no issues. But I don't love it. Kind of gross. Okay. All right, I'll fix that as well. But everything else is great. I don't think I need this ground here either, but I can slide this up a little bit and do an actual ground out. And punch it into this fill. Yeah, that'll work. Okay. Great. All right, so that's going to do it for our PCB modifications. I will come in and move these. I've talked about it like 5 times now of moving these resistors down here to be out of the way of the structural support. And then I think we're all set. I will go back and do a once over to make sure everything is just how I want it to be. And we'll be ready to place an order. Get this thing fabbed and assembled and back for testing. So that's going to do it for today. Appreciate you watching. This is, again, it's a little boring, but this is all the process you got to go through. Like, you got to spend some time going through all the layout and finding where to place stuff. And when you do, you cut off other paths and things, and it's just a giant game of pack and squeeze. So thanks again for watching. I hope everybody has an amazing day, and we'll catch you next time.